Ready? Okay. This is our experiment, Adam and Simon's experiment, and Chloe's going to help us. This is our experiment on what happens when you heat salty water. So we've just put 50 grams of salt into 250 ml of water. Adam and I both have previous knowledge regarding this experiment, but Chloe's never done it before. So we're going to ask Chloe to make a prediction, have a look what happens, and then we're going to explain it later on. Okay. Chloe, we've just put the salt into the water. We're now going to turn on the heat. Okay. So what do you think will happen firstly to the water when we heat it up?
It will evaporate.
Yeah, so what's evaporate mean?
It's when steam goes up in the air.
Yeah, and what about the salt? What do you think might happen to the salt?
It will stick to the bottom.
You think the salt will stick to the bottom? Okay, why do you think that'll happen?
I don't know.
You don't know, okay. Thank you very much. Okay, let's have a look at this on a particle level.
Okay. This diagram represents the water and salt particles before any heating has taken place. As you can see, the particles are in a liquid state. In this state, they are able to slide past each other. These particles have minimal energy and are still quite cohesive. The blue discs represent water particles and the yellow discs represent salt particles. These particles are extremely small and are unable to be viewed with the naked eye. However, to enable us to show what is happening at the particle level, we have represented them this way. We are also aware that there would be particles in the air such as nitrogen and oxygen outside the water-salt mixture. However, we are focusing on the physical change that occurs on the mixture, so we are going to ignore these particles.
Okay, so the water's been boiling, the salty water's been boiling for around about three and a half minutes now. So we're just going to have another look. Chloe, what do you think's happening at the moment to the water?
It's bubbling up and it's starting to evaporate.
Yeah, so that's so. Is there anything else you can notice?
No.
No, that's all. Very good, thank you. Let's have a look at this again on a particle level.
This diagram represents the initial stages after the water begins to heat. Some of the liquid water particles turn to gas and escape from the mixture. During this animation, it appears that the water and salt particles are vibrating. Representing the particles in this manner assists us to explain the difference between the particles in liquids and gases. In reality, however, the particles are moving in a straight line until they collide with the other particles, causing them to change direction. The heat added to the water particles gives them extra energy, which increases the speed of their movement, beginning to reduce the cohesion between particles and initiating a change from liquid to gas. We have represented these gaseous particles using red discs. As the gas particles leave the mixture, the water level reduces, but the difference is negligible at this early stage, so has not been represented.
Join us in.
You can just start.
Okay, Chloe, let's have a look. So we can turn the heat off. What's happened? So what did you think had happened? What's happened to the water?
It's evaporated.
It's evaporated, which means what? Where's it gone?
It's gone, up there.
Up there. So it's turned from
a liquid
into
a gas.
Yeah, what sort of gas? What was the gas called?
Steam.
Good girl. And what's all this at the bottom?
Salt.
Salt. So you're right, the salt did stay at the bottom, and do you know why the salt stayed at the bottom?
No.
No, so we'll have to explain that to you. That's it. Thank you, Chloe.
Yep. Give us a wave. This diagram represents the change from boiling point until all water particles have been evaporated. As extra heat is provided, the particles have more energy and move faster. This is reducing the cohesion between the particles and allowing more water particles to change from liquid to gas, causing the water level to reduce. The salt particles begin to separate from the water particles and adhere to the side of the saucepan. This occurs until all liquid particles have changed to gas and only salt particles are left. As the salt particle has a much higher boiling temperature than water, its particles do not undergo any basic physical change, for example from liquid to gas. Because the separation of water and salt particles using heat is a physical change, if we were able to contain the gaseous water particles or steam and cool them down or condense them, we could recreate our original mixture of salt and water. This is because the physical change is a process that is reversible.